today we are going to learn about inverse trig functions and solving simple trig equations, right? So we're going to start with inverse trig functions. And you should have seen inverse trig functions in Math 2 because you have to have them if you're solving any equation for an angle. So you've done a little bit of this, but in a more useful context. It was just like a tool you were using to solve a problem. You probably weren't thinking of it quite in the same context we're thinking about with graphs and unit circles and that sort of thing. All functions, the inverse results when you switch the x and the y, right? So that's the case for all inverses. So actually, it was such my warm-up was a good lead-in, right? I didn't even actually mean to do that, but it was here. We switch our x and y's whenever we're talking about inverses. So whenever we have inverse functions, like when we find an inverse, like if we have addition, the inverse is subtraction, right? If we have multiplication, the inverse is division. If we were squaring something, the inverse would be the square root. If we are taking the natural log of something, what's the inverse? E to the power, right? So exponentials are going to be the inverses of our logs. So I don't know if that's true for me to say everything has an inverse. Most anything we're going to deal with for sure is going to have an inverse, right? So trig, the inverse of trig is inverse trig. We didn't come up with a new name for it. It's not like addition and subtraction. We just say that the inverse of sine is inverse sine, right? So there are two different ways that these can be written. You should have probably seen this before, sine with a little -1. I do not think you have seen this notation, arc sine. Have you guys seen that before? These are just two different ways of writing the same thing. So inverse sine, which you've probably seen before, and arc sine are equivalent. And some textbooks use arc sine and others use inverse sine. And I feel like inverse sine is more prevalent, but they could put either one of these on our exam. And so we need to be familiar with that notation there. So if we have a statement like this, sine of pi over 6 equals 1/2, right? That comes from our unit circle, right? So it's sine of pi over 6. This is an angle. Equals, since we're doing sine, a y coordinate. Either from the unit circle or our graph of sine, right? So this is sine of an angle. So if we want to rewrite this with arc sine notation, we will do inverse sine here. That will cancel out our sine. We will get pi over 6 equals inverse sine of 1/2. Or sine inverse. Heard it both ways. Okay, so now this is still an angle. And this is still our y coordinate. So for this, I think it's helpful to understand what it means whenever you see inverse sine of 1/2. It means what angle has a sine value, which sine is our y coordinate, of 1/2. So when you are doing inverse sine, you are looking for an angle. Your answer is an angle there. And since everything on the AP exam is in radians, we got to remember that our angle is probably something like pi over 6, pi over 4, 3 pi over 2. Right? They're all going to be in radians. You can do it in degrees, but it won't be in degrees on your exam. All right, now, inverse trig has a problem because I'm going to pull this up over here in Desmos real quick just to show you what goes on. I can graph y equals sine x. That gives me this wavy graph right here, right? Well, if I switch the x and y's on this, now, and let me ask you this first. Sine of x, is that a function? How do we test functions? Vertical line test. Sine of x passes the vertical line test just fine. But if I switch the x and y's, that's like my first step in finding an inverse, right? Well, that does this to the graph, which looks cool. But does that pass the vertical line test? Not even close, right? It's going to, every point is going to have multiple, like infinite times that it hits that vertical line. So, whenever we are talking about inverse trig, we are going to have to restrict some domains in order to get values that are functions here. So, if we look at this graph, we need to pick a section of this graph that when we flip it, it can pass the vertical line test. We can tell that because if the graph we're looking at, like this is sine x, if it will pass a horizontal line test, then when we flip it, it's going to pass the vertical line test. So there's a lot of different segments that you could pick here, but the one that mathematicians sort of decided upon is this section right here. Right? That piece from negative pi over 2 to pi over 2 is going to be something that when you flip it, it can pass the vertical line test. This part can be a function if we restrict the domain. There. So these are sometimes called our principal values. I'm pretty sure it's principal spelled that way. There's a chance it's the other. I'll go check in a second. It doesn't say it later, does it? No, I don't think it does. For sine, we're going to restrict our domain from negative pi over 2 to pi over 2 to make this inverse sine a function. The calculator does this. So if you do inverse sine of a value, it will only give you answers between negative pi over 2 and pi over 2. So if you type in like inverse sine of 1/2, it's only going to give you the values between negative pi over 2 and pi over 2. Now, technically, there's infinite values, right? There. Cosine is going to be a little bit different because for cosine, we'd have to pick a different section, right? From pi over 2, I'm going to highlight this, but then I'll erase it. From here to here, would this pass the horizontal line test? It would not. You cannot restrict the domain to the same section right here. For cosine, we're going to go from 0 to pi. So for cosine, 0 to pi is our principal values. And then tangent, they didn't graph tangent for you here, but tangent, remember, looks like this at pi over 2 and negative pi over 2. You've got those vertical asymptotes. And then the graph does like this. And then it does like that again and again. And over here, does like that again. All right. So for tangent, you're also going to go negative pi over 2 to pi over 2. Okay, so we've got those three restrictions on our domains when we're talking about inverse trig. So let's look at what sort of stuff they're going to, well, actually, first. So that's, on the first part, I gave you a picture of what those restrictions look like from the graph. Let's also think about what that looks like from the unit circle, okay? So from the unit circle, if you're thinking about the unit circle, then for sine and tangent, we're just looking at the first and fourth quadrant, but there is something we need to make a note of here. In the fourth quadrant on your actual unit circle, you have values like 3 pi over 2 to 2 pi, right? So like 11 pi over 6 is in there, 5 pi over 3 is in there, 7 pi over 4 is there. But we're thinking of negative pi over 2 up to pi over 2. So fourth quadrant values are negative angles. There. And that's the same over here for tangent. For cosine, you don't have to worry about it, because for cosine, if you're using the unit circle to answer questions, you are looking at just the first and second quadrant. So let's think about what this means here. You will sometimes be asked to evaluate expressions for inverse trig. If they do not give you any other information than this is just finding inverse cosine of negative root 2 over 2. You need to use these restricted domains. They may not give you extra information telling you the domain's restricted there. So if I'm thinking about inverse cosine of negative root 2 over 2, let me just pull up the unit circle here. Alright, so on that unit circle, I'm thinking, where is cosine? So like this question is asking you, where or at what angle, at which angle does cosine of theta equal negative root 2 over 2? That's what that question's asking you, right? Inverse cosines, at which angle does the cosine equal this value? And so cosine is your x coordinate, right? And when we're looking at cosine, we're only looking at the top half of this unit circle. So we're only looking at the top half because of the domain restrictions that are implied by doing inverse cosine. And we're looking at our x coordinates for negative root 2 over 2. And so for our x coordinates, negative root 2 over 2, that happens right here. And so we will get the angle, which is 3 pi over 4. Whenever you are doing trig, or inverse trig, your answer should be an angle. Okay. For B, inverse sine of negative root 3 over 2 is saying, at which angle does sine equal negative root 3 over 2? Now, for sine, we're only looking in the first and the fourth quadrant. Okay, so we're looking in these quadrants. We're looking at our y coordinates. We're looking for negative root 3 over 2. Here it is at 5 pi over 3. But 5 pi over 3 is not your answer, okay? Because you're looking for answers between negative pi over 2 and positive pi over 2, right? Negative what? Yes, we're going to use negative pi over 3 instead. Okay, so anything in the fourth quadrant, you need to use that negative angle instead of using the one that we have written down on our unit circle for that. Does that make sense? And these are actual numbers. So like you're looking for numbers between negative pi divided by 2, which is like 1.7, negative 1.7-ish, and positive pi over 2. 5 pi over 3 is going to be a much bigger number. It's not between those two values, right? Tangent's the hardest one to find because tangent's not on the unit circle. Okay. For tangent, again, we are looking for values from negative pi over 2 to pi over 2. I've got square root of 3. Should I look in the first quadrant or the fourth quadrant here? First. How can we tell it needs to be first? We've got a positive slope right there, square root of 3, right? So since we're getting a positive number, that's not going to happen in our fourth quadrant, right? The slope of all these lines is negative. If we're thinking of doing y over x, we're going to do a negative over a positive. That will give us a negative. So it's got to be first quadrant. Is it going to be pi over 4? It is not, because square root of 2 over 2 divided by square root of 2 over 2 will just give us 1. So it's not pi over 4. Now, other than maybe remembering, because we've done it a few times, it's not immediately easy to see whether it's pi over 6 or pi over 3. A lot of times I forget myself, so I just test it. So I just find tangent of pi over 6, which would be the y-coordinate, which is 1/2, over the x-coordinate, which is square root of 3 over 2. And dividing fractions is easy as pie. Flip the second and multiply. 2's cancel. I get 1 over the square root of 3. Is that going to equal the square root of 3? It is not. I could quit now, but in case you want to see it done, you could multiply the top and bottom by the square root of 3. So we would get square root of 3 over 3 for that. So that's not it, so I'm going with pi over 3. It's got to be the other one, right? But if you want to check it, tangent of pi over 3 would be square root of 3 over 2 divided by 1/2, which would give us square root of 3 over 2 times 2 over 1, which is square root of 3. There. Questions? So our answer is pi over 3. Okay, one last type of question you're going to see here. They have given us a picture, and they are asking for inverse sine and cosine of certain values. So they only labeled this as xy, but I could label the rest of the points here. Q is going to be negative xy, right? The x-coordinate is negative in the second quadrant. I could label this point as negative x, negative y, and then I could label S as x, negative y. Okay, so the question is saying, for each of the following expressions, determine which labeled point intersects the terminal ray of the given angles, right? So we are answering this with a point S, P, Q, or R. One of these is not going to be our answer at all. All of this is inverse trig, right? For sine, we look from negative pi over 2 to positive pi over 2, right? This is the section we look at for sine or for tangent. Ooh, what happened there? And then for cosine, we're going to look from 0 to pi, right? Which quadrant do we not ever use for inverse trig? Third quadrant, right? This, for inverse trig, not ever going to be our answers, right? I think I accidentally did something where that went to the next line. So there we go. Nope, not enough. Okay. So if I'm not going to use r as an answer at all. If I do inverse cosine of x, that's saying where does cosine equal x? So cosine right here means I'm already only looking at 0 to pi. Right here. And I'm looking at cosine being my x coordinate. That is right here, so that would be point P. For sine inverse of negative y, I'm looking from negative pi over 2 to pi over 2, which somehow my picture's got. There we go. Let's put that back. There. Negative pi over 2 to pi over 2. And I'm looking where my y coordinate is negative y. Which point does that happen at? At S, right here. Right there we got negative y. So that would be S. Now, this does also happen over here in the third quadrant at R, but it's not a principal value. It's not in that restricted domain we have for inverse sine. Okay? Cosine of negative x. What would we get for that one? That one's going to be Q. And then tangent of negative y over x. That is S for that. Okay, questions? All right, we are going to take a few minutes here. And number 11, because they give you positive x, positive y in the fourth quadrant, right? So what's happening there is like you have to have a positive number then a negative number for that. But x and y are variables, they're not numbers. So what can happen there is that in that case, like maybe your x equals, you know, I don't know. I'm not going to get numbers that are exactly right, but x equals 1/2 and y, no, it wouldn't be 1/2. X would equal like 3/4 and y would equal like negative 1/3. I'm just making things up there. That's probably not actually on the circle. But the y value is negative right here, but they've called it y. So it's weird. It's a little confusing. So that means like up here, at this point P, the x coordinate would still be positive. It'd be the same, right? But what would happen with the y? It would have the opposite sign, right? So to do that, I'd have a negative y right here. And then I also need to know over here what's happening at Q. I actually don't really need to know R because R is in the third quadrant and is not going to be an answer for inverse trig, right? But at Q, the x coordinate is going to be opposite and the y coordinate would stay the same as point P right here for that. So this is kind of weird. You have to think, rather than thinking of that negative as being a negative sign, like meaning that that number is negative, think of that negative as meaning the opposite sign of. Okay, so like if they give us xy here, then we have the opposite sign of the y up here for that. So I feel like that's a little weird, those questions, because what you're seeing kind of goes against the quadrants. And you have to think about that a little bit different. I think once you get that set up, you can probably answer the questions okay there. All right, so in the notes. So I've got, put the screen on here. I've got sine inverse of x equals -1. It's asking us to solve the equation. All right, so we're trying to get x by itself. The first thing I would like to do is I do not want inverse cosine of 0. Okay, so on the unit circle, For sine and for cosine, I only want to think about the first and second quadrant whenever I'm doing inverse cosine. So inverse cosine of 0 is where does cosine equal 0? Cosine is your x-coordinate. So right here you got 1, 0. Right here you got 0, 1. Over here, negative 1, 0. We're looking at x-coordinate. So cosine of inverse cosine of 0, remember, is the angle where cosine equals 0. We're looking for the angle. What angle do I have right here? Pi over 2. So I'm getting pi over 2 right here. And then I've got sine inverse of x. Okay, any ideas now? We're trying to get that x by itself. Very good. So the inverse of inverse sine is regular sine, right? So we could, if we do sine of this side, sine of inverse sine cancels out over here, and we just have x. That means we're also doing sine of pi over 2. So sine of pi over 2. So x is going to equal, we got to do the sine of pi over 2. What is sine of pi over 2? 1. That is our y-coordinate here. So that's sort of what you're going to do on these problems. The part that has like no variables, figure it out using the unit circle, and then to get rid of an inverse sine, you would use sine. To get rid of an inverse tangent, you would use tangent, and so forth on those. For 1, you should get pi over 3. 2 is negative pi over 4. 3 is pi over 4. 4 is 5 pi over 6. 5 is negative pi over 6. And 6 is negative pi over 6. So this is sort of like the most important thing you need to be taken away here, being able to find that inverse, those inverse trig values. You're not going to be able to do really the other stuff if you can't do that. Questions here? Any of that giving you trouble? Tangent's a little tricky. I'm also surprised they did negative 1 over root 3 here instead of negative root 3 over 3, but that's what he did there. But you just have to think about testing the points, right? Okay, for 7, you should get 1. For 8, you should get square root of 3 over 2. For 9, you should get negative 1 over pi. And for 10, you should get the square root of 3. And then on the back side, for 11, A is P, B is Q, and C is S. And for 12, A is S, B Q, C P, D P, E P, and F S. Yes. 10 is square root of 3. Yep. Let me just pull up the blank copy for 8. No, that's not it. I've got too many things open here. There we go. All right, so for 8, the first thing you need to do is you need to find inverse cosine of negative 1/2. So cosine, we only look at the first quadrant, and cosine is your x-coordinate, and you're going to have negative 1/2 right here. The coordinates right here are negative 1/2 root 3 over 2. That is at 2 pi over 3. All right, so 2 sine inverse of x is going to equal 2 pi over 3. Once you do the inverse cosine, the trig for that right side is gone. It's just 2 pi over 3. So you're trying to get to this x right here. So you're going to divide by 2. I like to, instead of dividing by 2, since this is already a fraction, I like to multiply by 1/2. It's the same as dividing by 2 right there. And if you do that, you will get 2 pi over 6, but that reduces to pi over 3. So now we're looking at sine inverse of x equals pi over 3. And so for our last step, we're trying to get to that x, which means we've got to get rid of inverse sine. How do we get rid of inverse sine? Regular sine. So we will sine this side. That will just cancel out. We'll get an x. We will sine this side right here. And so we're getting sine of pi over 3. And before I started inverse trig today, that wouldn't confuse you, but it may now because you're getting things backwards. But sine of pi over 3, you're just thinking about where pi over 3 is at. The coordinates here are 1/2 square root of 3 over 2. Sine is your y coordinate, so you will get square root of 3 over 2 for that. Okay, we're going to do some more with some equation stuff, so I want to move on so that we get the last little bit of things done here. Okay, so if we look at these two statements here, we've got sine of x equals 1/2 and sine inverse of 1/2 equals x. And on the surface, they look kind of the same here, but they're not going to be quite the same because sine inverse has a restricted domain. So when we think of like doing an inverse sine of both sides of an equation, we have to be careful here because on the original right here, if I ask myself where does sine equal 1/2, on the unit circle there's two answers for that, right? Sine equals 1/2 right here at pi over 6 and also right here at 5 pi over 6. I've got two places where that happens, right? But inverse sine is only going to have one answer because it's in that restricted domain, right? So when we're solving trig equations, depending on whether they ask us for a general solution or a solution on a restricted domain, these two can actually be different ideas. So throughout the process of solving an equation, we might think of inverse sine, but if it was not an inverse sine statement at the beginning, it doesn't necessarily have a restricted domain, right? So this has no restrictions on domain. But when you use inverse sine notation, that does have restrictions on domain. Okay. In fact, they may ask us, like when I look at this right here, these answers, pi over 6 and 5 pi over 6, are only between 0 and 2 pi. But are those the only answers that exist? Right? I can rotate more than one time around, right? I could add 2 pi over, I could add 2 pi to any of these, and it's going to go right back to that same spot. Or I could subtract 2 pi, right? So this is a little bit like we saw with our vertical asymptotes for tangent. If I must write a general solution to a trig equation, okay, then I want to find the answers from the unit circle. So you can see here, pi over 6 and 5 pi over 6 are my answers from the unit circle. But I can also have any answer where I add 2 pi to that, right? So I could do pi over 6 plus 2 pi, or I could do pi over 6 plus 4 pi, or I could do pi over 6 plus 6 pi, right? Or I could subtract. So the way that we show that is we put plus 2 pi k where k is an integer. All right, so we're going to get our answers from the unit circle, and then we can put plus 2 pi k where k is an integer, and that'll cover all of the possibilities. All right. You'll see for cosine, it's similar. All right. We've got a cosine equation. We got 2 answers from the unit circle, and then we've got plus 2 pi k. What about tangent? Tangent's different here, right? What is different about this expression for tangent? First of all, it is, for tangent, they just have pi over 4. Right? They did not, there are 2 answers, but they did not give both of those answers. They just gave one. Because, excuse me, what's the period for tangent? It's just pi, right? So you really don't want to look from negative pi over 2 to pi over 2, because tangent already repeats on the unit circle. And then notice right here, instead of having, for these, we've got plus 2 pi k, because 2 pi is my period. Tangent only has pi k, because the period of tangent is pi for that. So let's try to solve a couple of equations before we go, okay? Find all solutions to the equation cosine of x equals negative square root of 2 over 2. So I could think of doing inverse cosine, but there's no restrictions on the domain because our original question is not an inverse cosine. So I'm thinking on my unit circle, negative root 2 over 2. So it's the pi over 4s where I get root 2 over 2. Right here, I've got negative root 2 over 2, positive root 2 over 2. And right here, I'll have both of them negative. Right? So this happens at 3 pi over 4, and this is 5 pi over 4. Since they're asking for all solutions, they don't restrict the domain, what you're going to do is you're going to say x equals 3 pi over 4, give the angle where this happens, plus 2 pi times k. And we can do that with the other as well. 5 pi over 4 plus 2 pi times k. And we need to say where k is an integer. So basically we're saying here's the 2 answers we know, plus you can spin around the circle, you know, and give coterminal angles for that. You don't always get 2 answers. For example, let's look at number 2 right here. Where does sine of x equal negative 1? At 3 pi over 2, right here, we got 0, negative 1. Right here, that is at 3 pi over 2. It is an acceptable answer to say x equals 3 pi over 2 plus 2 pi k, where k is an integer. I don't know if it's always the answer. You're going to see if it's multiple choice. What else could I call 3 pi over 2? What's another like coterminal angle with that I could call it? I could also call it negative pi over 2. So you might want to do negative pi over 2 plus 2 pi k. Sometimes they'll do that instead. You don't need both of them there. Just know that like if you don't see what you're thinking should be the answer, it might be because they've used negative angle values there. All right, we're going to do this one last one, and then we'll be done. I want to know where tangent is 1 over root 3. Tangent, 1 over root 3. I really only have to look from negative pi over 2 to pi over 2. It's got to be at pi over 6 or pi over 3. It's got to be in that first quadrant. If we try pi over 6, coordinates here are root 3 over 2, 1/2. If we do 1/2 divided by root 3 over 2, dividing fractions is easy as pie. We're going to flip the second and multiply, and we get 1 over root 3. So there it is, it's pi over 6. So we're going to say x equals pi over 6. But for this one, we just want to put plus pi times k. Because Tangent only has a period of pi. So we're just going to use this as our answer here. Okay, so that's as far as we're going to go with this.